Good evening and welcome back to AP Stats Notes Online. I want to wrap up Chapter 4 today or tonight, depending on when you're watching it, and talk a little bit about um, some sort of things that you should be aware of when starting to develop a study. Um, Make sure that we understand if a cause and effect relationship can be established, if we can generalize our results to the population. Um, and so we'll talk about that. We'll talk about some challenges that are going to be obviously some common sense stuff, some obvious stuff that we need to be aware of in trying to establish a causation. Um, and then I'll spend a couple minutes, and I think a slide that's not in your notes, to talk a little bit about data ethics. Just a quick rundown of some things that, in your future, um, if you find yourself in a position to where you're starting to develop studies, that you understand some of the things that you need to do, just as far as an ethical world is concerned. Um, so anyway, let's get started. Scope of inference is something that you've heard me say before, and what we mean is what type of inference can be made from a particular study. In other words, what kind of conclusions can we make once our study is completed? And that answer depends on how you decide to set it up. Um, we've talked about well-designed experiments need to randomly assign individuals to treatment groups, which is great, and that will help us establish some cause and effect relationship as long as we have a treatment involved. But unfortunately, we can't force people into our experiments, and so we do have to take volunteers, and that can limit the reach of our conclusions that we're going to make from our studies. On the flip side, observational studies don't randomly assign to groups. There's not a treatment involved, and so that creates some issues as far as trying to establish a cause and effect. But they do ideally you're going to be able to randomly sample from the entire population, and so whatever results we do get, we can at least project those out to the rest of the population. So when you're considering what type of inferences you can make, what kind of conclusions can you make, and again, inference is just fancy word for conclusion, from any type of study that you set up and carry out, we basically have to ask ourselves two questions. Were the individuals randomly selected from the population? And the other question is, were individuals randomly assigned to groups for treatment, right? So if we're going to answer yes to this first question, were individuals randomly selected from the population? If so, then would that be fair to take whatever conclusions you make and project that onto the rest of the population? And hopefully you're thinking, sure it would. If we don't randomly choose from the population, if we eliminate some of the population from being even eligible to be studied, then it wouldn't be fair. It wouldn't make sense to try to project any conclusions onto those people, since we have no way of knowing what they might be like or what they might say or what any of those individuals or how they might have affected our study. So if we randomly if we randomly select from the population, then yes, we're going to be able to generalize our results to the rest of the population. Were individuals randomly assigned to groups? If the answer to that is yes, did we take our individuals and randomly assign them to two groups, one being a treatment and the other one being a control of some type, then that is what allows us to establish a cause and effect relationship. And so we have this Punnett square thing going on that'll help you sort of hopefully visualize the questions you need to ask, and based on those answers, what inferences we can make. So if we're randomly selecting from the population, then yes, we can project our conclusions onto the population. If we do randomly assign groups, to randomly assign individuals to two groups, then yes, we can establish a cause and effect. We have a comparison to make sure that our treatment is actually causing the results, right? So on the flip side, in this square, I can give you a second to think about this as you're reading, but were individuals randomly selected? The answer here is yes. So if our individuals are randomly selected from the population, then can we make an inference about the population? Okay, and if individuals were not randomly assigned to groups, can we make an inference about cause and effect? Can we make a conclusion about cause and effect? I'll give you a second and let you think about that. And hopefully you're sitting there thinking, sure, we can make inferences, we can make conclusions about the population as long as we're randomly selecting our individuals from the population. But since we're not randomly assigning to two groups, then we cannot establish a cause and effect relationship. Now, next down here, were individuals randomly selected? If the answer to that question is no, then would that be fair to project your conclusions onto the population? And then, were individuals randomly assigned to groups? Would we be able, if the answer is yes, would we be able to make inferences about cause and effect? What do you think? And hopefully you're thinking no to the population, but yes to cause and effect. And then last but not least, were individuals randomly selected from the population? If the answer to that question is no, then can we make inferences about the population? And were individuals randomly assigned to groups? If the answer to that is no, can we make inferences about cause and effect? And hopefully by now you're thinking pretty quickly no to both of those. So those are the two questions you need to ask yourself as far as a study goes, either one that you're setting up or one that you're reading the results of. And based on the answers to those two questions, you need to start thinking about what sort of conclusions we're allowed to make from that particular study. What conclusions make sense. Okay? As far as establishing a causation is concerned, again, we talked about a lot, and the biggest difference between observational studies and experiments is this idea of establishing a causation. We need to have a treatment group, we need to have a control group in order to help us figure out if an explanatory variable does indeed cause a change in the response variable. Now, even in a well-designed experiment, something that we talk about a little bit is lack of realism can sort of limit the conclusions that we're allowed to apply in certain situations. The book offers up one as far as brake lights go. I'll let you look at that. That's a pretty interesting example. But another one I'll throw out there to you is, a lot of times in the medical field we have to experiment on animals. As much as PETA and animal lovers don't like that, it is this sort of bridge that we've established before we start testing on humans. The issue with that, and one thing that anybody should be able to point out, is the fact that while animals do share some physiological similarities with us, obviously they're not humans, and so very likely to respond in different ways to any particular treatment. So we have to be pretty careful about the conclusions we make when we're doing these animal testing or really testing on anything. If the population that we're interested in isn't composed of those particular experimental units. So, it's necessary, I suppose, instead of going straight to human testing. I mean, that would be the alternative to animal testing. But I would think that some people would at least agree that that creates some issues in and of itself. So there is this thing of lack of realism, and so when a study is done, when an experiment is done, that becomes an issue in trying to establish some conclusions. In other cases, it just isn't practical or even ethical to do an experiment. And there's some questions here that the book goes into. Does texting while driving increase the risk of having an accident? We would probably think so, but the last thing we want to do is randomly assign one group of individuals to text while they drive. and another set of individuals to not. Um, you're putting people at risk to real harm, and you can't really do that. Does going to church regularly help people live longer? Well, again, the same issue. You can randomly assign two different groups, but can you force people to go to church, or force people to not go to church? And then the biggest one is, smoking. Does smoking cause lung cancer? How could we possibly know that for sure? I mean, it's not like we locked a bunch of people in a room and made them smoke 6 packs a day, and took another group of people and said you can't smoke ever. I mean, there's just a lot of ethical and practical issues with that. So experiments aren't always available for us. So can we make a strong case for causation if we can't do an experiment? In other words, how do we know smoking causes lung cancer? Why do we even talk about that? There are some ways. If you can't do an experiment, then there are some criteria for establishing causation even from observational studies. And these are very important, that all of these things have to be present and in order for us to use an observational study. A well-designed experiment with treatment and control is still the best way to establish causation, okay? But it's possible. So the first thing is the association strong, right? In other words, do we have, in the smoking and lung cancer situation, we have a bunch of smokers that do develop lung cancer. So there is an association there, and it's pretty strong. Is it consistent? Again, as we're looking at smokers, are they consistently getting lung cancer? And so I guess going back to the first one, is the association strong? Is there a high rate of lung cancer in smokers? And do we continually see smokers getting lung cancer? Looking for that consistency. Larger values of the explanatory are associated with stronger responses. In other words, is it true that if you smoke more, you are more likely to get lung cancer? And there have been a ton of studies that have told us, yes, that is the case. The more you smoke, the higher your risk is. And the alleged cause precedes the effect in time. In other words, we have to make sure that the smoking happened first, and then the lung cancer was developed. I mean, you can't really take a look at a bunch of people that have developed lung cancer and then go back and see if they smoked. We got to make sure that the cause precedes the effect. So we got to make sure that the people were smoking first and then developed lung cancer. And then the last one is the cause plausible? I mean, does it make sense that by inhaling this smoke into your lungs, that it might affect your lungs and cause you to develop lung cancer? And I think that anybody with some common sense would say at least it does make sense. So those 5 things have to be there in order for us to establish a causation from an observational study, but it is possible. And smoking and lung cancer is definitely one of those examples. Okay. All right, last but not least, and we'll do this pretty quickly, not anything that you need to spend a lot of time worrying about, but there are ethics involved when you're doing experiments. There are some standards that are set that are just some common sense things. Number 1, all planned studies must be reviewed in advance by an institutional review board charged with protecting the safety and well-being of the subjects. So medical studies go through rigorous review all the time to make sure that nothing is being done to further harm any subjects, and then they're closely scrutinized by these review boards to make sure that they're being run properly. Obviously, any individual that's going to take part as a subject in a study needs to give their informed consent. And last but not least is that all individual data must be kept confidential. While we will release statistical summaries over the entire group to the public, obviously we're not going to release any individual information, at least we're not supposed to. We have to keep that stuff confidential. So just the things to keep in mind as you're talking about and reading about and hearing about studies that are set up all the time. Okay? So really the biggest thing here is knowing what kind of inferences we can make, if we can make it about the population, if we can project our conclusions to the population, or if we can make our conclusions about cause and effect, know when we can do that. Understand that there is some issues in trying to establish causation if the experiment is exactly real, as far as testing on animals and trying to project that onto what would happen to humans is an example. There are many more out there. And then if we can't do an experiment, it is possible to still establish a causation. It's just very, very hard, and there are a lot of things that have to happen in order for that to be the case. So, and that's it. That's it with chapter 4 and setting up our studies. Now we know where our data is going to come from. We'll start after chapter 4. Talking about what we're going to do with the data once we have it. So we're going to work towards a test at the end of next week, so start studying for that. We'll do a lot of things this week leading up to get ready for it, and we'll start on Monday. So enjoy the rest of your weekend, and we'll see you guys on Monday.